one of the NLP text processing technique called bag of words. And if we take bag of words, it has two main disadvantages. The first one is its sparsity. So if we take any vector of a review or a sentence, what happens here is this vector will be having more number of zeros compared to the non-zero elements. So as the data increases, this sparsity will grow exponentially. So that is one of the main disadvantage of bag of words. And the next disadvantage is it doesn't consider the importance of words in the sentences. That is, what bag of words does, it converts the text into vector, and in the output vector for every element the weightage will be given based on the occurrence of it, not based on the importance of it. So maybe to explain it better, I'll take an example here. Let me take an example of a review of a product. So maybe the review is the quality of a mobile phone is good. So if I want to find whether this particular review is a positive or a negative, how will I find it? I'll go through each and every sentence in the review, right? So as soon as I see the word good, I'll come to the conclusion, okay, this review has the word good in it, so it's a positive review. Same way, what bag of words will do, it will also does something similar to what we do. It will go through each and every word in it, and it will uh, instead of thinking about the importance of it, what it will do, it will count the occurrence of it. So first it will see the word the, and it will count, okay, how many times the word the occurs, it occurred two times. Then same way it does for all the words, and it will come to the word good, and it will see, okay, the word good occurred one time. So that's how it calculates the weightage of every word in the sentence. So it will give the weightage of 2 to the word the and 1 to the word good. And that doesn't make sense, right? Basically, the word good should be given more weightage compared to the word the. So that is one disadvantage. One another disadvantage of bag of words. So, in order to overcome this, what we are going to do? We are going to our next method called term frequency and inverse document frequency, and in short, it will be called as TF-IDF. And if we want to look at some history about it, and this TF-IDF was initially developed for information retrieval. So if you want some examples here, we can take any search engine. Let's take Google for example. If you go to Google and search something, and what we will see a list of results, right? And how do you think the results are arranged, on basis of what the list are being sorted? So if you see, like, the more relevant one should be on the top, right? So for that, what they have done is there is some ranking algorithm which does those things. So TF-IDF was initially used in those areas to rank the pages in search engines. So now, since we have seen a little history about it, now let's see the actual implementation and how TF-IDF works. Now let's see the calculation part of TF-IDF. That is, how to convert the text into vector using TF-IDF. Unlike bag of words, in TF-IDF we have the formula, and using which we are going to convert the text into vector. And from the name, we can see it has like two factors, right? One is term frequency, other one is inverse document frequency. And the formula for term frequency is number of times the word occurs in the review divided by total number of words in the review. And the formula for inverse document frequency is log of total number of documents divided by number of documents which contains the word. And to calculate TF-IDF, what we need to do is we need to multiply TF with IDF. Now we have seen the formula of TF-IDF. Let's interpret it. So before interpreting it, let me show you few reviews I have collected. So these are the reviews of a mobile phone. So now let's see like what are the important words in this review. So let me take the first review. It has the words like camera, quality, phone, amazing. So these are like the most important words in the review, right? Because using these words, we can identify whether this review is a positive or a negative one. And again, if I take review 2, it has the words like love, sleek design, performance, again phone. And then if I look at review 3, it has smartphone, best battery life. So when I look at these kind of words, I can easily come to a conclusion like what this review is saying, right? So these are the important words in these review. And now let's look at some different type of words, right? The words like the, of, this, is, and again in the review too, I have the words like I, the, and. So these words are like very less important ones, right? Because these don't add much meaning to this sentence. So what we want TF-IDF to do is it should give more weightage to the words like camera quality, amazing, and less weightage to the words like the, of, this, is. So this is what we want to achieve here. And what the formula for TF says is, so again, if you take TF, it's very similar to bag of words. So the formula, the numerator of the TF is exactly same as bag of words. So what we do in bag of words? We count the occurrence of a word in the sentence, right? So that's the same thing. I just rewrote it in a different way. Like number of times the word occurs in the review. And what denominator says is it says the total number of words in the review. So what exactly it means is if I take the word like camera, so what we are doing is we are first on the numerator part, we are just counting, okay, how many times the word camera occurred in the review? One time. So we have to put that in the numerator, and in the denominator we have to put how many words are in the review. So basically 1, 2, 3, 4, 5, 6, 7, 8. 8 words are in the review. So this is how TF works. But in IDF, what we say? In IDF, let's ignore log for now. Let's see the other part, like total number of documents divided by number of documents which contains the word. So what it does is it will basically count how many reviews are present in my corpus, like in my data set. So totally I have here for the IDF, I totally have like 10 reviews, right? So the numerator will always be the same for IDF and only the denominator will change. Let's take, for example, the word the. So let me count how many times the word the is present here. So my first review has the word the, second review has it, third review has it, and again fourth review it's present, fifth, sixth, seventh, eighth review doesn't have the word the and it's present in 9, 10. So basically out of the 10 reviews, 9 reviews has the word the. Okay, now let's look at the other one like camera. Okay, so camera is present in the first review and again it's not there in second, third, right? It's present in the fourth and it's present in the sixth. Yeah, so for camera, if we take the IDF value, so it will be, the numerator will always be the same, right? So it will be 10, that is the total number of documents divided by 3. So you can see, right, when we do the calculation, the IDF for camera will be higher compared to the IDF for the word the. Right. So that's how IDF is being calculated. So basically what's happening is what TF does is it will look at only a single review. But what IDF does is it look at the whole document. So TF, the value of TF will be high when the word is more frequent in the review, right? You understood, right? Because like in TF, we are just calculating the occurrence of it. So if a word is occurring more frequently in a review, then the TF value will be more. Same time, if a word is occurring less frequent in the whole document, then the IDF value will be higher for that, right? So if I want to say it in a very simple terms, if a word is present more frequently in a review, the TF value will be high. And if a word is very less frequent, that is very rare in the document, the whole document, then the IDF value will be more. So that's how TF-IDF is calculating the weightage of every word in a sentence, right? So now let's take an example and I'll explain you step by step how exactly the TF-IDF value is being calculated. Okay, so here I have taken the example best camera phone in the market. So what I'm going to do here is I'm going to convert this sentence, that is this review, into vector. So first what I need to do, I need to calculate the TF value, right? So as per the formula, what we have to do in the denominator, we should have the total number of words in the review, right? So total, how many words do we have in this review? So I have like one, two, three, four, five, six. So I have the total number of words is six. So the denominator will always be six. And the numerator part, what we are doing is we are basically counting the occurrence, right? So how many times the word best occur in this review? One time. How many times the word camera occurs? Once. Again, phone once. In the market, so every word occurs exactly once, right, in this particular review. So the value of TF will be 1 by 6, 1 by 6, 1 by 6, 1 by 6. So for everything, it will be 1 by 6. Now let's calculate the IDF value of this particular review, right? So again, for that, first let's look at the formula. So what we have here, numerator will always be the same, right, for IDF, total number of documents. So here I have taken like just two documents. So what will be the denominator numerator here? The numerator will always be 2. Again, for the denominator, we need to see we have like two documents, right? Basically two reviews. In how many reviews, so many documents, the word best is present. So if I just look at this one, best is present basically in both the places, right? Totally we have two reviews and in both the reviews we have the word best. So so I'm putting the word putting two here. Again, now let's look at the camera. So again, camera is also present in both the places. So it will be two. Phone. Again, phone is also present in both the review. So it will be two. In the market. So these values are present in only in the first review. So I'll be giving the weightage of one. So at the end, how IDF will look like is we have a log here, log of, so all the numerator will be same, right? Because we will place the total number of reviews. So it will always be 2 in this scenario. And in the denominator, we have to place this one. For the best, it will be 2. Camera, it will be 2. Phone, it will be 2. For the rest of the things, it will be 1. And here what I'm doing is, so it will be log 2. 2 by 2 will be log 1. And again, these values will be log 2. So I'm just calculating the actual value of it. So after that, this is not the final step. Now we have only calculated the IDF, right? In the previous step, we have calculated TF and now we have calculated the IDF. And the final step will be we have to multiply the TF with IDF. So these three values are zero, so definitely when we multiply a value with zero, we will end up with zero. And for these three things, I just multiplied, actually I have multiplied the 0.693 with 1 by 6. So because for all these things, we have the TF value of 1 by 6, right? So I'm just multiplying 1 by 6 with 0.693 and basically ended up with 0.1155. So this is the TF-IDF value of our review, best camera phone in the market. So we have basically converted the review best camera phone in the market into a vector form. This is the vector form of that review, right? Same way you can do for every review in your sentence, right? Now let's understand why we are having a log in the IDF. So to know it, let me take an example here. Let me assume we have a total of 100k reviews and each review is having 10 words. So if I want to calculate the TF of any word in the review, what will be it? The denominator will always be 10 because I already have made the assumption that every review is having exactly 10 words. So the denominator will always be 10. And then what about the numerator? So in the numerator, we are counting the occurrence of it in that particular review, right? So it will obviously will be less than or equal to 10. So TF of any word will be less than or equal to this particular value, right? So whether the word is a less important one or a most important one, the TF value will be always less than or equal to this particular value, right? Now let's go to the IDF calculation. So in IDF, we have two things. So first we will calculate for the less important words, then we will go for the most important ones, right? So let's take words like and, the, this. So these are like very less important ones, right? So to calculate the IDF, again here the numerator will always be the same for every review, right? Because the numerator, what the numerator is, it's a total number of documents in the corpus. So how many documents do we have here? We have 100k documents. So the numerator here will always be 100k, and the denominator. So to calculate denominator for words like the, let's say we can safely assume, right? The word the will be present in almost all the reviews, right? So we can directly put 10,000 here. So in that case, if we calculate IDF, the value will end up being 1. So maybe we can take one more scenario. We can assume one more scenario. Instead of thinking the word these present in all 100,000 records, let's assume it's present only in 90,000 records, 90,000 reviews. So in that case, how do we calculate IDF? The IDF will be 100,000 divided by 90,000. So the output will be 1.11. Again, this value is very close to 1, right? So this is how these are the values. So these values are very low for the IDF values are very low for the less frequent, less important words. Now let's take words like groundbreaking, which are very rare in the document, and these are like very important words, right? So to calculate IDF for that, again, the numerator will be the same. So we will put 100,000 here. Denominator, let's assume the word groundbreaking is present only in two of the documents. Out of the 100,000 documents, only two of the documents is having the word groundbreaking. So in that case, if we put 2 here, the result will be 50,000. So let's take one more scenario. Let's assume out of the 100,000 documents, in 10 of the documents, we have the word groundbreaking. So in that case, if we put 10 here, the output will be 10,000. So we see the difference between the less frequent and the less important and the most important words. So if we compare the IDF values for the less important ones, the IDF value is very low, and the most important ones, the IDF value is very high, right? Again, uh, if we at the end, right, we need to calculate the TF-IDF. For that, what we need to do? We need to multiply TF with the IDF. So if we multiply our TF, this is our TF with values like 1, 1.1, 1.11, so that's okay, right? But if we multiply the TF with values like 50,000, 10,000, what will be the result? Right, the TF, the IDF will always be dominating the TF, right? Because these values are very huge compared to the values which we will be getting from the TF. So at the very end, what will happen? The IDF will always dominate the values. And we don't want that to happen. We want to give equal weightage to both TF and IDF. So how to resolve this issue here? So in order to resolve this, we are introducing a log. We are introducing a log to the IDF. So what log does is, so we have here 10,000, right? If I take a log of 10,000, I'll be getting 4. So in order to reduce the values, of the IDF, I'm introducing a log. So this will help me in reducing the value of IDF so that IDF will not dominate TF, and at the end both TF and IDF will be having equal weightage. Okay. Now let's look at the implementation part. So in practice, if you look at, we don't manually calculate the TF and IDF values for every review in the document, because we may have like 100,000 records, right? So manually calculating for every review in the document, every review in the corpus is a very tedious task. And again, it is more prone to manual errors. So we don't do that in practice. Instead, what we will do is we will use some libraries to achieve that. So one such library is scikit-learn. So here, if you take the scikit-learn, the IDF value is little, IDF formula is little different compared to our definition, right? So what do you think the difference is here? So again, the log, it is the same thing. And in the numerator, we have the total number of documents in the corpus. And the denominator, we have the document frequency of T, which is nothing but number of documents which contains the word. So these are all the same thing. So the new additional stuff which is being added here is we have added a 1 to the numerator here, and again we have added a 1 in the denominator here, and again at the very end we have added a 1. So we have basically added 1 in 3 places. So why basically scikit-learn did that? So why scikit-learn made these additions to the original formula? So to understand that, let me take an example here. Let's take a word like the. So we already discussed, right? The words like the are very less important words, and it will almost be present in all the documents in the corpus. So if you want to calculate the IDF of it, how do we do that? So we have the original formula, right? Log of total number of documents divided by number of documents which has this particular word, right? So we have already assumed our corpus size is 100, so the numerator will be 100, and the denominator again, the word the, we can assume again it will be present in all the documents, so the denominator will also be 100. So the numerator and denominator will cancel out each other, and we will be having log 1, which is nothing but 0. So once the IDF becomes 0, automatically the TF-IDF value becomes 0, because basically we are multiplying the TF with the IDF value, right? So for less important words like the, in scenarios where they are present in all the documents, the output, that is the TF-IDF output, will be 0, right? So, and we don't want that to happen, because once the TF-IDF value becomes 0, that particular word will be entirely ignored, right? Even though the word is very less important, we don't want to completely ignore it. We need to have it, but we need that word to have a very less TF-IDF value. So in order to handle that, what we are doing is we have added a 1 at the end of it. So by adding a 1 to it, we will not end up having 0 IDF. So wherever we are ending up with 0 IDF, it will be handled since we have added a 1 at the to it, to the value of the IDF, right? So now let's look at the other ones. So again, we have added a 1 to the numerator and 1 to the denominator. Why did we do that? So again, to understand that, let's take some example. So for example, let's take any ML application, and it will always have a training and a test phase, right? So during the test phase, let's assume that we see a word which is not present in the training data. So in that scenario, how do we calculate the IDF value? So the IDF will be, as per the formula, we should take a log of total number of reviews divided by number of documents which has this particular word. Since this word is not present in the training data, it will be 0, and it will lead to division by 0 error. So we don't want this to happen, right? This scenario to happen. We don't want to end up with division by 0 error. So in order to avoid such scenario and avoid such errors, what scikit-learn done is it just added a 1 to its numerator and its denominator. So by adding a 1 to its formula, what it really implies is it says Okay, maybe we can look at the formula and we can itself come to the conclusion, right? So we have added a 1 to the numerator. So what the numerator holds? It holds the number of documents in the corpus, right? So if you add a 1 to it, what that means? It means, okay, if I have like 100 reviews in my corpus, now I'm going to assume, no, I don't have 100, I'm having 101 reviews in my documents. And for example, if I take a word like groundbreaking, now initially what happened is in my out of my 100 reviews, the word groundbreaking is present only in 2 reviews. Now by adding a 1 to it, I'm saying like, okay, the word groundbreaking is now present in 3 reviews, right? Understood? So by adding a 1 to the numerator, we are saying that we have seen an extra document, and by adding a 1 to the numerator, we are telling that my particular word is also present in that extra document. So if you want to see that data visually, I have created an example here. So let's assume a two review scenario. I have only 2 reviews. Mobile is good and expensive. Mobile is cheap. So as per the new definition given by scikit-learn, we are just adding a 1 to the numerator as well as the denominator, right? So that means we have added an extra document, and the document will be the collection of every word in the whole corpus. So since here we have like 2 reviews, the extra review will be mobile is good and expensive cheap. So it basically holds every word in the corpus. By doing so, in the denominator, we will always be seeing that our word in all the in the extra document, right? Okay, so that's the reason why scikit-learn added the +1 in all these 3 places to avoid all the edge cases, to handle the edge cases, right? Now, let's see how TF-IDF value is actually being calculated using scikit-learn library. So here I have pasted the result which I got from scikit-learn. So for our example, let's take the word market and let's take this TF-IDF value. Let's try to calculate this. So here we have the TF and we have the IDF here. So IDF here we have the loan, and how do we calculate? Here we have the total of 2 reviews. So I have added a 1 to it, and the word market is present only in my first review. That's the reason I have added 1. So again, all the 3 plus 1s I have added. So and again, 2 plus 1 will be 3, 1 plus 1, 2. So this calculation, IDF calculation is clear now. But you may ask me, okay, IDF I understood. Why are we having 1 in TF place? It should be 1 by 6, right? Because that's what we calculated in the previous step. So it should be 1 by 6. Why are we showing 1 here? So the answer to that question is, again, this is some modification which scikit-learn has done. So again, for to calculate the TF, scikit-learn is not using the actual formula. Instead, what scikit-learn is doing is it's using the count vectorizer. So count vectorizer is nothing but the formula which we use to calculate the bag of words. So in bag of words, what we do? We just calculate the occurrence of words in the review, right? So basically, this is the bag of words output. And again, this is the IDF output. So once we multiply it, we will be having 1.4054. So this is what scikit-learn gives us. Okay. Now, let's look at one more thing. So let me assume like, okay, I have like few hundred reviews and my IDF values looks like something like this, okay? Like for one of the word, the IDF value is 1. For another word, it's 50,000. Like another one, 100,000. Another one, simply 75, 94. So this is how my IDF value looks like. Now, how do you come to the conclusion like which is the important word in this sentence and which is the least important one? Maybe you can say, okay, one is the important one, sorry, 175, 94, these are like least important ones, and 50,000, 100K. So the words which are having these values will be the most important ones. You can say that, but we don't know, right? So this is for a single review. what will happen if we have like 100k reviews, and we want to know like what are the words which are less important and what are the words which are more important. We want to print that out. How do we do that? We can't, right? Because we don't know the upper and lower limit of this, right? By looking at the data, we are saying, okay, these are the highest values, so I'm taking this. These are the lowest values, so I'm putting it into the another category. But if you don't look at the data, you can't come to any conclusion. So that is one big problem we have here. To resolve that, what scikit-learn again does is it does a brilliant thing. It just normalizes the data. So it will just normalization is nothing but here we don't have any upper or lower limit. So instead scikit-learn put everything between the limit 0 to 1. So once we do the normalization, every value will be present between 0 to 1, so that we can easily assume like we can have like okay values which are present between 0 to zero point 0.5 or less important features, and 1 to 0.5 or the most important words. We can come to that conclusion, right? So scikit-learn by default it uses L2 normalization. Again, we can switch it. If you don't want to apply any normalization, you can set it, and if you want to apply L1 normalization, you can change this value to L1. So you can basically modify, you can try out with different values, but if you don't specify anything, then by default scikit-learn will apply L2 normalization. Okay. And that's all about the theoretical part. Now let's look at the actual implementation of it. And the implementation is very simple and it's very similar to bag of words. So what I'm having here is my corpus of data, that is my entire data set. So here I have taken only 5 reviews just for the simplicity. And these are all the reviews about smartphones which I took from Amazon. And how we are going to implement TF-IDF. So first what we need to do is first we need to import a class called TF-IDF vectorizer from sklearn. So that's what I'm doing here. So after importing this particular class, I'm going to create an object of it. So I have created an object called vectorizer from the class called TF-IDF vectorizer. And now after creating the object, I'm calling a method called fit transform from this class. So to this method fit transform, I'm going to pass my entire data set as an argument to it. So once it's done, whatever we get as an output for this one is our actual vectorized output. So this is what uh, TF-IDF does. So finally I have added a one extra line. So what this line does is it just converts my vectorized output to an numpy array and finally transforming it into a pandas data frame. So why am I doing this is just for the visualization purpose, just to show you the actual output. And here what's happening here is we are just getting all the feature names, so that is all the unique elements from the data corpus. And now let's look at our output. So if you see the output here, the words like the this, they are given less importance, right, compared to the words like performance, quality, resolution, smartphone. So they are given more importance compared to these words. And again, if you look at the word phone, this is again given less importance. That's because the data set which we have here is the review of smartphones, right? So obviously the word phone will be part of every sentence. So it actually makes sense that why TF-IDF gave the word phone a less weightage. And this is not 100% accurate because we have like a very less data. We have only 5 reviews. So with any machine learning model, as the data increases, the accuracy also will increase. So if you want a better output, all you have to do is just increase the data set. So yeah, that's all about TF-IDF. And if you see again, like bag of words, again TF-IDF also has like two main disadvantages. The first disadvantage is sparsity. So you can see like a lot of zeros in the output. And the second disadvantage is it doesn't capture the relationship between the words. So we know like with TF-IDF, it actually considers the semantic meaning of the sentence, but it doesn't actually capture the relationship between words. So maybe if you take two words like king and queen, so we know, right, king and queen, they are related, but TF-IDF, it doesn't know that. Again, if you take words like tasty, delicious, so they all mean the same, right? But if we give those words to TF-IDF, it will consider those two words as entirely two different things. So that is one another disadvantage of TF-IDF. Yeah, that's it about this video. So if you have any questions about the concept or about the code or anything related to TF-IDF, please feel free to comment. I'll try my best to answer. Thank you.